Hello, Munich. Hello, Indiana. Hello, Orange County.
Welcome everybody to OpenCV weekly webinar. And today we have with us Joseph Nelson, who is the CEO of RoboFlow. RoboFlow is a silver partner of OpenCV. Thanks for the support, Joseph. And they are an amazing company and they are dedicated to helping the community. That's the best part about RoboFlow. Every time you have come to this show, you have provided so much value to our audience. And we keep these things two separate. What RoboFlow actually does and what Joseph actually comes and promotes here is really education, right? So we love having you on the show. Thank you for your presentations have been very popular on the show, so we keep bringing you back on the show.
I really appreciate it. It's a privilege to be able to join the webinars we have here, and I think today is the show that I'm as excited for as any, being able to talk through the year in review of everything that happened in 2021 in computer vision and some big predictions. The trouble with predictions is they're about the future. So as you know, it's difficult to be completely right, but it'll be a nice time for us here. And yeah, I appreciate you saying kind words. We're eager supporters of the open source community and at RoboFlow, building tools that enable folks to have access to computer vision technologies is core to our ethos. So leading with education, leading with tooling, leading with value and empowering developers is in our DNA. So it's a privilege to be able to join you for this session.
That's great. And also with us is Phil Nelson, not related to Joseph Nelson. He's the content manager at OpenCV. Hi, Phil.
Good morning, everybody, and thank you again for joining us on this Thursday. Let's ponder our orbs with computer vision predictions.
Sweet.
So I'll introduce us here. So today we're going to be doing, as discussed, computer vision and AI predictions for 2022, which relies on setting the foundations of a review of 2021. Phil put together here a wonderful graphic of the orb on the right and included the subtitle, an orb pondering conversation. I think Phil's been able to sneak an orb into the last 3, if I'm not mistaken, OpenCV webinars. With you today, so Satya, of course, who leads the OpenCV team. We'll talk more about OpenCV in a moment. I'll describe and introduce myself, then turn it over to Satya. I'm Joseph Nelson. I'm the co-founder and CEO at RoboFlow. At RoboFlow, we build tools that enable developers to use computer vision in their applications. That includes everything from making applications that can identify, say, the tennis balls at Wimbledon, where RoboFlow was used this year for powering instant replay technology, to backyard things like identifying when there's a squirrel or a bird at your bird feeder, a hose that turns on to squirt the squirrel versus ensuring the bird is at a bird feeder is one of the recent use cases I heard of someone in Colorado building with RoboFlow. And we'll talk a bit more about the tooling and how we empower and enable that mission in a moment, but I'll give Satya a chance to introduce himself formally.
Hello, everybody. To all the RoboFlow people who are joining from the RoboFlow audience, I'm the CEO of OpenCV.org. And also to people, usually I don't even introduce myself and we just add my name later on when we do the editing. So I'm the CEO of OpenCV.org. And as many people know that OpenCV is the biggest computer vision library in the world. We've been around for about 20 years. And still growing, adding new features every time. So that's a little bit about OpenCV.
And notably, in addition to the open source library, OpenCV has wonderful courses and a partnership with Luxonis, with whom RoboFlow also worked closely to release hardware devices, the OpenCV AI Kit, OAK devices. I had the pleasure of joining Luxonis, Brandon, the CEO at CES this year in Vegas. We were staffing the booth together, and it was awesome to see technologists and hobbyists alike getting their hands on the cameras and being, this is a 4K camera, and it also does depth, and it also runs, real-time inference at the edge. So it was, it's an awesome piece of technology, and certainly a part of our 2022 predictions, to spoil the lead a little bit.
Yeah, I mean, OpenCV itself has grown a lot beyond the library, right? Initially, the foundation was dedicated just to support the library, But then we decided that, look, OpenCV is so much more than the value that we can provide to the community is so much more, because we are people from the industry, and we develop the library for people who, for it to be used in the industry. But then there are other opportunities that we were seeing, in education, in edge AI hardware, etc., that were just mind blowing. And we just decided that, look, OpenCV just cannot be about the library. It has to grow beyond the library. And that expansion will continue in 2022 as well. And as Brandon keeps publishing on Twitter and LinkedIn, Oak has many different variants that are coming out this year. And it's going to be a wonderful year for Edge AI as well. And on courses, we are about to launch deep learning with TensorFlow and Keras. And there are some more interesting courses coming this year.
Can't wait.
Yeah, and also some surprises. Stay tuned.
As always.
Yeah. There's some interesting competition also coming together. Should we just leak that information? Phil? No, okay.
Another couple of weeks.
Okay, fine. All right, let's go ahead.
That's a great tease. You guys. So at RoboFlow, we, as discussed, make the building blocks that enable developers to add computer vision directly to their products. And as you know, computer vision systems can be complex. Everything from collecting data, organizing data, getting things annotated, training models, deploying models, monitoring those models, and continuing that kind of continuous active learning loop requires quite a bit of tooling, expertise, and capability. And so RoboFlow enables teams to focus on solving their domain problems instead of reinventing the wheel, so to speak, on given portions of the computer vision lifecycle, and gives them a leg up to get to production more quickly and use best-in-class tooling. So, I mean, I prefaced this earlier, we've seen everything from tracking tennis balls to identifying damage on roofs from drone imagery to measuring fish, counting public transit occupancy. And what's been really fantastic is, developers are incredibly creative, capable types who always stretch the uses of the technology in ways we can't even imagine. And that's translated not just from amazing hobbyist use cases, but to enterprises as well. So now over half the Fortune 100 have developers that have used RoboFlow to bring computer vision solutions to production. I mentioned earlier our focus on being a open partner of OpenCV and the open source community more broadly. Some of those efforts include making it easy to use best-in-class models on models.roboflow.com, or enabling users to have data sets for public use and consumption on universe.roboflow.com. And so we're constantly aiming to make it easier and lower the barriers to entry for using computer vision in given products.
So one of the things that surprised me, last year was, I never inquired, which are the companies. I always knew that a lot of companies were using RoboFlow, but I did not think that these top, Fortune 100 companies, or maybe even Fortune 50 companies, if that there is such a term, are using RoboFlow. I was pleasantly surprised, when one of the very large retailers came to us and they said that, oh, we use RoboFlow, and they wanted to build.
Hey, I know that guy. I've heard of RoboFlow.
Right. So it was very interesting.
We're big believers in the Chris Dixon quote that, what the hackers do on the nights and weekends, the Fortune 500 do in 5 to 10 years.
Right.
And that time cycle has been rapidly accelerated. It appears 5 to 10 years was 5 to 10 months. So it's been great to see the continued adoption of these tools for organizations that want to have best-in-class tooling and robust machine learning operations pipelines.
Right.
So let's jump right into our year in review. So jumping right into it, I think one of the biggest things that happened, Satya, in 2021 was transformers making the jump from natural language processing tasks directly into computer vision. And you can see what a transformer doing computer vision looks like on the right here on my slide. A transformer understanding the world.
A new one has been released.
So, I mean, to give some context as to why this is significant, historically in neural networks, they've been based on architectures of convolutional neural networks. Geoffrey Hinton introduced foundational seminal paper that demonstrated we can use convolution to, in some senses, better interpret and shrink the pixel space to better understand imagery and ingest video and imagery in pixels successfully. And over the last 2.5, 3 years, an architecture known as transformers, which is a modification of recurrent neural networks, but allows operations that are previously serial to happen in parallel, demonstrated some state-of-the-art advances in text processing and creation of things like BERT and other notable seminal models. And those hadn't quite made their jump to computer vision yet, of how do you process pixel data in the same way of using transformers and attention to better understand pixel level data. And in 2021, that shift happened. So I have some stats here where there are transformers-based architectures that beat CNNs in classification. So for example, Vision Transformers, VIT, was able to demonstrate 90.45% top 1 ImageNet accuracy. So that means, an ImageNet, the classification data set where you have a number of objects and you want to know and classify what's present in that object. Top 1 accuracy refers to when that model makes a guess, it makes a number of guesses for which classes. When that top guess that it's making, how often is that guess correct? And Vision Transformers took the cake in terms of beating out CNNs, an efficient net, which is a large CNN model. And while this looks like it's sort of a small marginal change, I mean, you're like, Joseph, why are you so excited about 90.45 compared to 90.2? It's a meaningful shift in terms of the foundations of how we can process text data or image data, and increasingly what that means for the combination of image and text data, which is something else we'll talk about. In object detection, the task of finding bounding boxes in images, we've similarly seen an improvement in transformers. So Florence, which the Microsoft research team introduced in November of this last year, achieved a 62.4% map on the COCO dataset, Common Objects in Context, which previously Yellow R held the state-of-the-art record at 57.3% map in COCO. And so it's a bit more of a notable delta than the even just ImageNet change. But again, the notable thing here isn't simply, number goes up. It's the way in which the number goes up and how we're identifying new foundational ways of modeling the world around us. So the key idea, the bullet point here is transformers have enabled a new stepwise improvement in computer vision modeling and lays the foundation for new ways to understand text information. And so I think this is this observation here of like this finding feeds into some of the other ones that we're going to get to discuss of what happened in 2021 in review. But this is really a bedrock trend that I think is only going to continue to accelerate if the world of natural language processing is any kind of indication.
That's really good. Yeah, so there are these jumps in technology that happen very often, and it's very difficult to say where, when those jumps have happened. But there are clear jumps. For example, we used to have shallow networks, right? They used to be just one layer. And then the first jump happened when we started having deep neural networks, more than one hidden layer, so that you could learn a higher level of abstraction. You can learn more things by having these layers of abstraction. So that was another jump. And for images, there was another jump. These fully connected neural networks, as you made the layers deeper and deeper, they became very difficult to manage. The number of parameters exploded. And with convolutional neural networks, we saw a jump where the parameters were in check because the number of convolutional neural networks typically have much fewer parameters compared to a fully connected layer, because each pixel is not being connected to each node in a network is not being connected to the other node in the next layer. It's using this convolutional kernel, so the number of parameters was significantly reduced while retaining the learning power, right? It was, and our brains also learn in those in that way, right? Our brains trigger things when we look at edges and things like that. So the that shift from fully connected layers to convolutional layers, that was a huge one, right? That made computer vision, deep neural networks really work on computer vision problems. And now with transformers, there is a huge possibility of this paradigm shift. 2021, for our consulting business, for example, we waited. You don't jump into everything new that comes along, right? There was capsule networks and there were other things also that looked very promising, but you have to wait for some time to see how this thing is coming along. And transformers, one of the things that people can do is, we benefit when people in the community, not just the computer vision community, but let's say the NLP community, the speech community, they are all using the same tools and the same kind of architectures, so that, we understand each other's language. And that happened. First of all, the tools happened, right? We had TensorFlow and PyTorch, which work on image data as well as NLP, whatever you want, right? Speech data. So now we are using the same tools. And so we could actually work on each other's problems. For example, in our consulting business, we worked on a speech, denoising problem. You can remove the keyboard noise and barking dog noise, etc. But just 5 years back, we would not be able to take on that project because we were not speech people, right? We were vision people. But we could do that because, the tools are the same. I just need to read a few papers and we'll be in good shape, right? Now, with transformers, that's the benefit, that if the architectures are also same, then there is a smaller learning curve, and there is also cross-pollination of ideas. The advances that are made in NLP, for example, they computer vision automatically gets a free benefit. We did not do the research; those guys did the research, and we get this this additional benefit for free. And that's the promise of transformers, and we are very excited about this ourselves. Definitely something.
Yeah, I think you raised a really good point in that when everyone's using the same tools, those improvements to the tools kind of flow bidirectionally, and it's a snowball effect where I think when we've seen the results of that snowball effect, and as we were talking about before the show, just how quickly the advancements are now like reaching even consumer level tech with machine learning.
Right.
Guess how many years it took for the refrigerator to reach mass adoption as defined by consultancies?
Wow, I don't know.
Like 50% of the like middle class population, something like that?
Yeah.
I don't know, 20 years?
20 years?
Yeah. Commonly reported as 50 years.
Wow.
And and at the same time, technologies like the ones we're talking about, like, fintech or financial technologies, arguably, done that in a decade, right? And things in machine learning of this nature, we're still in the very, very early precipice of what's possible. And I think Satya and Phil, a comment that you all are making that is quite notable is, at the model level, transformers represent a shared representation of the world between text, image, and even audio. And so when we find these advances in architecture at the modeling level, it can kind of flow through. Now, at the data level, there's still pretty significant differences, and sometimes on the deployment level, that can be true as well. But the convergence at the modeling level is particularly notable and will allow us to continue to accelerate these advances. In terms of, this is kind of like an implication of transformers in some ways, but in reviewing 2021, there was the rise of multimodal models, right? So as opposed to saying, I'm just going to be modeling one type of data, so just imagery or just text or just audio, there's been the rise of modeling problems that include context from two types of data. So commonly now increasingly seeing image and text being modeled through single architectures and model releases. And so, for example, in January 2021, right out of the gate, OpenAI released CLIP, which is a model that was trained on 400 million image text pairs. Now think about how this differs from your traditional classification problem. Your traditional classification problem is maybe you have 400 million images, but you have kind of a single word, a single class association with each of those images. When you do it as a free form text, as like you can think about it like a caption or Instagram caption or someone commenting on Reddit or things like this, then the model can learn both the embedded text space and the embedded image space to have a more generalized understanding of what types of words describe what types of pixels and what types of imagery. And that change accelerated quite a few other opportunities throughout 2021. And if I'm going to make a prediction for 2022, it's that we've just scratched the surface of what this means for multimodal model capabilities. I mean, I saw a paper that was published where someone provided plain text instructions, like to a robotic arm that was like, pick up the red block and set it to your left, type that. And then the arm was able to understand all of that context and then execute on that task, which is really, really amazing. It's, the difference between what, you could see a direct path to in science fiction and magic in some senses. One other advance on this is Microsoft's research then built on top of CLIP and released a model called Florence, which is a foundation model in computer vision. And so foundation models are these models that are these mega models that take many, many days of GPU time to train and then contain such a rich amount of information that they can consider foundational. And so Florence was able to achieve a top one accuracy of 83.7% on ImageNet, as reported on the previous slide, has the state-of-the-art record on object detection. And really notably about this was, I talked earlier about the work RoboFlow does to advance the dataset community. Microsoft actually benchmarked the performance of Florence, the current state-of-the-art best model in computer vision, on a basket of data sets, not just from Coco, but also from RoboFlow. And so if you go to public.roboflow.com, you'll see a number of data sets, dozens of data sets for which users use for training, like things for dice detection, or perhaps thermal imagery or drone aerial imagery, cell counting, all parking spaces, aquarium fish, all of these things. And what the Microsoft team did is they took a basket of 11 public data sets from RoboFlow, so I have a screenshot of the paper on the right, and then compared the performance, zero-shot performance of Florence on this data set. And so I'm quite bullish on this because this represents not just benchmarking against Coco, but trying to create benchmarks for specific types of tasks and the ways in which increasingly open data and open improvements allow the proof of improvement that we're seeing more broadly. I have some more comments here, of course, but I'll let Satya chime in with some thoughts on this advance and how that might frame 2022.
Yeah, so I just wanted to give one other example of multimodal data in case people may be thinking, oh, what are the application areas? One great application area is in medical diagnostics, for example, right? If you want to get data, for example, let's say even pneumonia or something, right? Lungs, COVID or something like that. You could get that data and you could get it labeled. It's a very tedious, laborious process to do it, right? But you could easily, and you can go only so far with that, right? Because this data requires, the labeling process requires experts, right? You need a doctor to look at this thing and say that, oh, this is pneumonia versus this is not pneumonia and things like that. On the other hand, if we are able to say that, okay, we want free-form text, in that case, you have so much historical data that you can get, X-rays, that were taken decades back with the doctor's diagnosis, right? Even in handwritten text or something like that. And if you can combine this, now it becomes a humongous data set because this thing has been going on for many years. Even if you count, okay, I'm just going to look at the last 5 years, the amount of data that you can get as soon as you say that it is going to be freeform, it is just huge. It's just enormous. Similarly, if you want to do, let's say if you want to analyze games, like let's say a soccer game or a football game or something like that, in that case, if you want to tag everything manually, it's very difficult. But let's say you use audio, the commentary that goes along with the video, then you have a very, very large data set. So those are two examples that show how text as well as speech, when used in freeform with vision can produce these systems that are almost self-labeled, right? You don't have to go through this tedious process. It's not easy to do, but those are two examples.
That's a great point, that the multimodal nature of things means the labeling burden is also lessened, because instead of saying, here's a bunch of images queued up, doctors tell me what's the quality of these scans, instead you might already have existing, imagine, I guess maybe the hardest part of this problem is going to be to read the doctor handwriting, if you've ever seen doctor
Yes.
handwriting. But once you have the
or programmer
associations.
handwriting, let's be honest here.
Or programmer handwriting. Once you have the associations of the write-ups of imagery, perhaps you can use that data without needing to have the same burdens to data preparation. And then the last thing I want to note on this is what this enables for zero-shot capabilities. So zero-shot means you're not training a model on, in this context, images. You're just using an already trained model and seeing how it performs on those images. So imagine that you take Florence or Clip and you pass it an image from an aquarium. Can it find the fish without even ever knowing anything about the aquarium? Can it find the fish in that image? The answer is yes. So zero-shot tasks and advancement in computer vision means getting to value more quickly from being able to understand the world around us without needing to necessarily have a large collected data set. So this lessens the activation energy to beginning to use models in meaningful ways. Now, this isn't to suggest that you don't need any level of fine-tuning. We still see that fine-tuning produces net better results. So you perhaps have a zero-shot approach initially to see how this works on your task. And then you use the data from your context to fine-tune the data set. Yes, just like transfer learning, someone wrote in the chat. And so fine-tuning is a way to basically get kind of the best of both worlds, where the activation energy is lower for getting a model ready and fine-tuned and into production.
Cool.
Yeah, I just dropped a Monty Python link in the chat there. If your brain is broken like mine is, you're just going through that sketch in your mind now.
Amazing. All right, so one other advance to talk about, this one's pretty fun, is the advance of generative models. So generative models are not new. Things like style transfer have been around for a while in computer vision, though there's been an introduction of new architectures that I think take generative modeling from purely toy and hobbyist to, oh wow, there's some meaningful ways we can create new data here, or we can create assisted creativity. So to give examples of that, on the right-hand side, you have a very shortly trained model to say, what does a raccoon on a tractor look like with steering VQGAN with Clip. But then also on the right, you have these Pokemon. And if you're like me, you're like, oh, I haven't kept up with Pokemon, so I can't name those Pokemon. In fact, no one can, because those Pokemon were synthetically generated. So Max Wolf, a data scientist at BuzzFeed, created a generative model that generates Pokemon like those you see in the image on the right-hand side. I'm gonna go out of full screen mode so I can grab a couple of links that I've prepared here. One of which is the BuzzFeed quiz. I'll drop this in the chat. You can generate your own Pokemon using this BuzzFeed quiz. And then one other one I'm gonna drop in the chat is, if you want to create your own generative AI, I've put a link from the RoboFlow blog of using Clip and VQGAN. And there's a YouTube video in there too that walks through how to use generative model techniques. Totally open and totally free and fun to play around with.
Yeah, huge fan of Clip and GAN. I've used it to do some images for my band, the Monster Association, using Google Colab, which it's not just fun, but it's so amazing to be able to play with the state of the art, like actually play with it like a toy, despite the fact that it's this crazily advanced, relatively new transformative technology.
Another interesting website is This Person Does Not Exist. I think that's the name of the website.
Yeah, that's the one.
When you go there, it just shows one picture of a GAN that has generated a picture of a person. And occasionally you can see, if your eyes are trained, you can get, you can see the problems, little problems here and there. But on first, if you are not thinking that, oh, this could be a fake image, you can be easily fooled. And many of those images, I would say about 50% of the images can even fool trained eyes, right? Maybe less, maybe 30%, but still there's quite a substantial number of
Especially if you
characters.
limit the exposure, like how long they're able to look at it. I think
Yeah.
if you give someone, 5 seconds, even experts are going to be fooled some of the time.
Right. So
Totally.
that's the promise of these GANs, that they can produce synthetic data from by learning. So it opens up a whole bunch of, so the applications are huge in terms of, you could use them for synthetic data creation, but you could also use them for these creative tasks like Pokemon cards or whatnot.
And the one other fun stat here is OpenAI introduced DALL-E for generating images from text prompts, also in January 2021. And a group in Russia wanted to open source and create DALL-E. So the GRU DALL-E was introduced, which is actually currently the largest computing project in the country of Russia, totaling over 24,000 GPU days to train the model, which I think is,
Wow.
just gives you a sense of the
Holy
mega model
smokes.
thing that's happening here.
Yeah, that's a lot of compute.
Kind of a short one here. The chip shortage slowed the development of progress in machine learning, especially true for democratization. If you're a hobbyist, you might not have been able to get your hands on an NVIDIA Jetson as quickly as you would have liked. Now, I do think there's a fair call out here. Luxonis, the OpenCV AI kit, Oak devices have surprisingly bucked this trend. I mean, huge credit to the team for launching a couple, not one, but a couple multi-million-dollar Kickstarter campaigns to bring edge devices to the masses in a chip shortage era. But that said, not everyone can
delivering
be
4 months in advance, actually. So we had promised an April, and actually this was a known thing. We took a risk on this. We said that it is going to be released on April, even though there is a small chance that we would be able to pull it in December. So we took a hit because a lot of people who were backing us on Kickstarter campaign, when they saw that April thing, they were obviously, April is far away, right? This was in October or something like that, and they were turned off by that. But we decided that that's the way to go. We will under-promise and over-deliver rather than the other way around. And so things just lined up, and all credit goes to Brandon and his team. It was so pleasant because most of the people were expecting a delay even in the April date because of the chip shortage. So a fantastic job.
Shout out to the Luxonis team for, I mean, it was a huge amount of work to basically not just some things we got lucky in a few aspects, but they spent so much time, re-engineering things even to be able to use parts that were available. Yeah. We've talked about it many times on the show, but there are certain simple components that used to be like 1 week lead time that are now 6 months, a year, even longer. And some of those are not easy swap outs. It's really, really something what they've been able to do. So, shout out to the Luxonis team on our side for sure.
And so I think it's truly an impressive feat, and I want to give the chance to basically call that out. Broadly, the NVIDIAs, Intels of the world cannot say the same. It's both slowed, certainly, the research rate at which things can happen from GPU shortages at the industrial level, but also the hobbyist adoption too, of being able to have access to edge devices. And unfortunately, a 2022 prediction, I don't expect this to slow. If you're seeing the same estimates I am, we're still kind of backed up on these things.
Yeah, definitely not out of the woods with the hardware stuff, and it's unclear even how large the woods are at this point.
So we talked about a number of predictions, but we can rattle off a few. I bullied Satya into putting 4 down, and I've put 6 down, and so we can talk through a few of these in a short bit of time before we
definitely weren't working on these moments before the show, everybody.
Yeah, so what I want to focus on are the areas that I feel will take off, right? And instead of focusing on specific algorithms, but because that can change, very quickly. right? The specific techniques people use, but AI is here to stay, right? And the expansion into new fields is just mind-boggling. In my newsletter, I wrote about, even 5 years back, we used to focus only on a few different kinds of problems. Like, let's say, most of the problems we used to get are classification or detection problems. Even in detection problems, we would be focusing on, people detector, people counting, or car counting, very straightforward applications. But now it's expanding into various fields. There are companies that are using this thing for handbag classification, because people are uploading pictures of their handbags and reselling it. So they need to provide a quote. This company is a secondhand reseller of secondhand handbags. So they need to provide a code, but they need to identify the handbag automatically before they can provide a code, right? Simple example, but you can see that how it has expanded suddenly. The things that used to be done by humans, they would be able to handle, let's say, hundreds of handbags a day, having a team of visual, inspecting people. But now suddenly it has gone, completely autonomous, and they are able to use machines to do it. And this is just one area. This is the tip of the iceberg. So we are going to see the expansion of computer vision into many different fields that we are not even thinking about right now. For example, this handbag classification problem that we dealt with a couple of years back, I would not have thought about this as an application area because I'm not in that fashion world to make that prediction. So things will come up where people generally, get aware about computer vision, and they see that, oh, we also have image data. How can we use another, even in medicine and manufacturing, etc. What we are seeing in terms of automation is just the tip of the iceberg. For example, in 2017 or so, we saw that ChexNet was able to beat human level accuracy in, I think, pneumonia prediction, in looking at chest X-rays. But that's just the start. Now you see computer vision being used extensively in all kinds of diagnostic tasks, right? Wherever there is radiology, or wherever you want to look at X-ray data or count cells, everywhere where things that were being done by people, counting problems, but not car counting or other things, right? You're counting cells. Those things are really taking off in a big way. We are getting so many projects where it is still classified as an image classification, object detection, or segmentation problem, but the domains are so different that it's heartwarming that how much time and energy we are saving. Similarly with manufacturing, agriculture, even space. There are, like you said, that in International Space Station, RoboFlow, some of the RoboFlow technology was used. Similarly, some of our friends are working on landing stuff on Moon, for example, and it's expanding. And a lot of people don't know that even the black hole, the imaging of the black hole, it's basically a computer vision problem that we saw, I think, in 2019 or 2020. I cannot remember exactly. The first image of the black hole was produced using Event Horizon telescope. And that is actually a computer vision problem, which was used. So similarly in photography, if you look at photography, just used to be better quality images, but things that we are seeing now, people are using photography in an augmented reality way, right? It's not just they want to take a good picture. I'll give you an example. Earlier, people used to take pictures in real estate photography. They would use Photoshop artist to clean the photo up, etc. Now, a lot of that stuff is becoming automated, right? For example, when they take real estate photography, one of the common things they do is sky replacement. Because the sky could be not blue, right?
Especially here in San Francisco, sometimes it just looks like a post-apocalyptic nuclear winter outside. Yeah.
right? So one of the very common tasks is to go and replace the sky. And that's not trivial because there are these trees and other things that can come in the way, and you need to do alpha matting to actually replace the sky. Now, Photoshop has a one shot, so AI has become part of Photoshop in so many different ways that we don't even think about it. You can go and replace the sky. It's a alpha matting and segmentation implementation. But our company went a step further. We have completely automated the process. We detect that there is a sky and then we replace it, right? So things like that, where it used to be a simple photography problem, but now it is no longer a simple photography problem. You want to enhance the photo in many different ways automatically, not somebody sitting there for 1 hour with Photoshop doing this, but you want these photos to be perfect. Even look at all the photo applications like Instagram and Snapchat and all others. They heavily rely on computer vision, and that trend is going to continue, right? Similarly, in simple things, if you look at the new version of iOS, when you take a picture,
and Mac OS.
And Mac OS, when you take a picture, yeah, the text in the picture is copyable, and they just, they didn't even make a big deal about it. They just released it. So everything, wherever you have a camera, they are going to get smarter and smarter, and you will just feel that your life just got better in subtle ways without realizing that, oh, this big thing happened. No, things are improving. Wherever you have a camera, those cameras are getting smarter and smarter, right? So do you have any thoughts about this, Joseph, Phil?
One of my first predictions is the rise of edge devices, which is associated with this idea, just as much as the fifth prediction I wrote down was that we've hit the tipping point where consumer technology has on device quite robust processing for doing things completely at the edge, and machine learning just becomes an embedded part of the product in ways that you don't even realize, just in the ways you're describing with Photoshop, or Androids have the ability to auto remove someone from an image and post editing. You just kind of tap them, or objects of significance. I mean, our customers, one of them is Cardinal Health, the Fortune 50 healthcare company, and they're embedding computer vision directly into their products in ways consumers would never anticipate. It just kind of feels like magic, and that's possible because they're deploying these technologies to actually things like iPads and other places. And now iPads have such powerful chips that at the edge, you can run everything directly there. And so there's quite a few.
Actually, that's also my second prediction. If you could go to the next slide, so we can talk about this. Carry on. Sorry.
No, actually, I think for the sake of time and whatnot, the more we actually merge our predictions, the better. So if you want to chat a little bit about Edge AI, and I accidentally spoiled the lead on number 3.
We've got some great questions coming in, so let's keep rolling on the slides so we can get to those.
Right. So Edge AI, first of all, the cameras, right? Earlier we started seeing that, oh, the cameras are getting cheaper and cheaper. They are getting smaller and smaller, and still a reasonable quality that you can use. But now we are seeing that the cameras are also having, processing. For example, if you look at OpenCV AI Kit with Depth, the retail price of OD was $300, and just, a year and a half back. And now we literally took it, the Kickstarter price was $74, right? That is just incredible. I mean, of course, when we got it to $74, it was pretty much, at cost, but you can still see the promise. Once the volume is there, the price can actually be, in the 50 to 70 range. And look at the power this device provides, right? It has 4 trillion operations per second, 4K camera, and it can do depth in real time. It can run all the neural computing. So it's getting very inexpensive, so that, if you have a $200, $300 product, this camera could be part of that you can have the camera as part of that $200, $300 product. The second thing is that
in terms of the price, the individual parts of what it does used to be $300 each. It's so impressive to me.
Yeah, and the second thing with Edge AI is the privacy concern that people obviously do not want everything to go to cloud. There are certain things people are very comfortable residing on the cloud, but not everything, right? For example, I really don't want the robots that are going on around in my house to store the camera images. They have cameras in the cloud, right? So if people can guarantee that these photos, when you use image as a sensor, privacy, the only way to ensure privacy is that it doesn't leave the edge device. So those are the two reasons I think Edge AI is going to take off. Massive reduction in price and computing and privacy concerns.
Yeah, and even especially if that device is air gapped to not even have a network connection, which you can totally do with those.
And the third one is basically robotics. So robotics, people have been saying for a long time that, small robots, I'm not talking about cars. I feel that, this autonomous vehicle thing has been a massive failure in terms of, people were predicting, Uber was predicting, and many other car companies were predicting that by 2020, we will have autonomous driving. And when 2020 came, they actually fired on their entire autonomous driving unit. And so that is still not happening very quickly. On the other hand, there is a rise in small robots, right? Roomba used to be the only robot that produced vacuum cleaners, right? But now we have other ones like Ecovacs has this thing called D-Bot. And Roomba didn't even have cameras initially. They were bump sensors, but now they have camera sensors for SLAM. And this other one, Ecovacs D-Bot, for example, it actually does. It's not using, it's using LiDAR for SLAM, but it's using an actual camera for object avoidance and things like that, right? It's almost like an autonomous driving unit inside your house. So this trend is going to continue. It is, small robots, drones with camera become a very useful sensor. Think about traffic monitoring. Think about all the inspections. Wind inspections, for example, are very expensive, very difficult, but you can do them with a drone equipped with a camera. So the small robotics where you have drones and these autonomous robots. We have, even on our webinar, we have had several people who did autonomous lawnmowers, a few companies that have done autonomous lawnmowers. So that trend is happening, which also 2 and 3 are very much related. The reason robotics is taking off is that all these sensors, not just the vision sensor, but all these sensors are becoming very, very affordable, and you can put them in the robot, etc. The one piece also that augments these trends is displays are terribly difficult, right? But now with cell phones, displays are clunky. The hardware, let's say a touch display, it's very difficult to implement a high quality touch display. It raises the price substantially. But with mobile phone,
very, very expensive. Yeah.
Yeah, but with mobile phone, they have gotten rid of the display problem. It's not their problem. You just connect it to a mobile phone, and now you have a display which they have paid for separately, right? And very high quality display that they have paid separately, and a controller as well. So all those things help 2 and 3 quite a bit. And the final thing is augmented reality and virtual reality. It's an adjacent technology to computer vision. There's a lot of overlap. That is taking off, and no matter what you think about Zuckerberg, you cannot ignore when he makes a decision, right? You have to pay close attention to what he's up to. And I actually bought an Oculus Quest 2 over this winter, just to try it out, what are the things. And I played ping pong for the first time using using my virtual paddle. It is very compelling. I was pleasantly surprised how far this thing has come. There are little problems here and there, but if you're talking about the next 3-4 years, I think this is a huge, huge area. Apple is going to make headsets. Microsoft is acquiring Activision, and
Microsoft has asked the FCC for permission to acquire Activision. Let's keep it
right. And Snap is also pretty big out there. So all these companies, they are investing heavily in augmented reality and virtual reality. It's very much conceivable that these areas will definitely take off. Whether they have sticking power or not is a different issue. But in the next 1 year or so, there will be massive investments in these technologies. So something to look out for, definitely.
There was a question in the chat I saw about computer vision's play in the metaverse, and will it be used? And the answer is absolutely. I mean, the way, basically what we're describing when we say metaverse is we're saying digital representations of physical things. What computer vision is being able to ingest unstructured data and be able to write software for real world objects. In fact, this is where RoboFlow got its roots, is we were making computer vision applications to make board games more fun to play. And we found that the tooling was quite limited and released our internal tooling externally so people could do the same. So in terms of having, you described Facebook's metaverse and how soon it'll be for you to have sweet baby rays from Mark Zuckerberg in the metaverse sort of thing. That's all we're dependent upon, having computer vision to recognize those sorts of objects and enable those capabilities to come to life.
Yeah, and just to make metaverse possible, it is all computer vision. Think about the technologies that go into creating these devices. The headset needs to have very high quality eye tracking, right? They need to have all the things, calibration, all the things that are essential to creating the headset. The software piece is heavily computer vision dependent. And then once you have a high quality device, the assets that you need to create, they also ideally what you should be able to do is have some device or some scanner and rotate this object that you want to put in your metaverse, right? And get a 3D representation of that object, right? So all those technologies that are required to make metaverse very easy and smooth, they are computer vision based, right?
Yeah, definitely. Let's pause here and do trivia before we hit 10 o'clock. We've been having such a good time prognosticating on the future of computer vision that we're almost up on time. So I'm going to go ahead and do our trivia question. If this is your first time joining us, the way that this works is that I'm going to ask a question which I've pulled from the slides today. I'm going to ask that question to you in the Zoom chat audience, and you're going to answer the question in the regular Zoom chat window. The first person that I see on my screen answer the question correctly will win a beautiful RoboFlow swag bag. I have one myself. I actually used the little raccoon backpack when I traveled back to Michigan, so thanks for that. It was great to hold my boots. You can probably use it for other stuff, but it's my boot bag now. So get ready to answer our question. Earlier in the slides, Joseph described that a model overtook YOLO RD6 in object detection accuracy. What was the full name of that model? Oh man, Richard, you got me. Looks like Richard says, yeah, Florence Coswin H, which is correct. It's 62.4% is the new state of the art, apparently. So congratulations, Richard, with the quickness. Do we want to go back to the slides, or we want to take a couple questions before we call it a day here?
No. We have the whole prediction from Joseph. I'm really sorry I ate into so much of the time.
Yeah,
Totally
let's
fine.
keep rolling.
A lot of my predictions were based on the things that we reviewed in 2021. I'll
Yeah.
go through mine relatively rapidly, and then
All right.
we can kind of shift to Q&A. And folks that are able to
So,
stick around for 5 minutes after, perhaps that'll work.
yeah, great. Go for it.
So the things that I kind of called out here, one is the further rise of edge computing. We talked about that at length. The second, this is somewhat a prediction, somewhat maybe a wish, the demise of COCO. COCO is a data set from Microsoft, which is fantastic and introduced in 2014, 80 classes, common objects and context. But computer vision tasks are increasingly domain specific. Just as Satya mentioned, wanted to see computer vision in medicine, manufacturing, retail. And I think those require retail or domain specific benchmarks. How does your model perform on small objects? How does it perform on thermal imagery? And so, the prediction here is based on seeing the RoboFlow data set used by Microsoft Research in creating a basket of data sets to evaluate Florence on, and using those 11 public data sets to do so demonstrates a trend. And so I don't think that that's an anomaly. I think that's a sign of things to come. The third thing that I want to call out is the mutability of data sets are the future and the now. I don't know that this is so much a prediction as it's here today. In research, you're commonly iterating on the model and holding the data set constant. In production, the opposite is true. You're holding potentially the model constant, but your data is constantly changing. And so we like to think about this at RoboFlow as having mutable data sets, understanding your data set, being able to improve and use active learning by default. Ender Ing calls this, data-centric AI. I think that's a great way to brand it. The idea that you have the need to be close in contact with your image data to better understand the environment is absolutely key. So much so that I think machine learning engineers are perhaps too obsessed on, do I need to go from YOLO R to Florence, or do I need to go from YOLO v4 to YOLO v5? And in reality, the higher value, probably use of time is maybe hold YOLO v4 constant for a moment and get the more data that is going to be representative of the problem that's going to be solved. That's my controversial take, perhaps.
No, that's actually a very popular take now with, if you look at Dr. Ender Ing recently, maybe a couple of months back, he said that, they use this phrase called data-centric application development, where you fix the model. His thing is that, the model you have chosen is probably right? And he gives several examples where optimizing the model produces zero improvement. You can spend days and nights and weekends, weeks and months on this thing. It's not going to produce results. But if you look at the data, clean it up, all these very annoying tasks with data set, that's where you get the biggest performance benefits, because data is never clean. You can do a lot with improving the quality of the data. And I like to say that a good data scientist is a good data janitor. So
it's a big, messy world out there for sure.
Right.
Absolutely. Yeah. So I think data-centric AI is a great branding for this. I like to think about it as mutable data sets. And this is a thing that we're really focused on making easier with our tooling at RoboFlow, is increasingly seeing it be adopted by large companies is indicative that we're onto something on that front. Model interpretability will continue to grow in prominence. So I think this is especially key. It goes hand in hand with the idea of mutable data sets, but also the ethics of computer vision, knowing how a model comes to a decision, knowing the attributes, being able to change things, fine tune things, stress test things, depends on how you're identifying the way the model comes to its conclusions, which neurons are being activated, what's firing, where are the issues, gaps in your data set, to be able to ensure the model is representative of the real world conditions. And so I often like to say that in computer vision, ethics and computer vision actually often run hand in hand. Having a representative data set is not just the right thing to do, it's also going to ensure a better outcome and better performance of your model.
I have a slightly different take on that, on interpretability. So if you look at many things in medicine, many things in even engineering, we do not understand how things work very well, but they work. For example, even Jan LeCun likes to say that people don't know how an aircraft flies, right? The physics that we use to explain how an airplane flies, it's very rudimentary. I mean, it's good on paper, but if you actually look at how the airflow flows on the edge of the airplane, etc., it doesn't make sense. It's very difficult to explain what exactly is going on. We don't understand how airplanes fly. Medicine is full of examples, right? We don't even understand the basic mechanisms of why this popular drug works. So it's a lot of experimentation. So we cannot interpret. We actually do not have we don't have good visibility onto how these things work, right? So we are unable to interpret them, but they are still very, very useful, right? They are still very, very useful. So I don't disagree with, that for fairness, interpretability will be is very useful and probably even required in some cases, but in a lot of domains, it may not be necessary, or even it can sometimes be counterproductive also, right, for emphasis. But if you ask me where the trend is, I think the trend is definitely towards more and more interpretability.
I think you're right. It begs the question of who needs to know, right? So does the end user necessarily need to know how the person was removed from your Photoshop? Not necessarily. But for those that are improving and developing these features, then yes. So I think you're right. And that's kind of oxymoronic that we both, as AI gets more widely adopted, fewer people need to know how the feature is working to, recommend the movie they want to watch. But those that are developing the systems need to know even more about how the systems are coming to conclusions.
Yeah, another way to say it might even be like auditability. Like you need to be able to understand post facto how it arrived where it arrived for a given output.
I'll run through these last ones here. I think we talked about 5 at length. We'll hit a tipping point in consumer access to advanced computing technologies. Things like the M1 being equivalent to 2040 Ti NVIDIA chip already coming shipped to the mainstream as an example of that. Multimodal, I think, is going to come to video. To be fair, I made this prediction last year and I had to eat my words. I'm making it again. I think multimodal is going to make it to video in terms of the same way of scene detection. And there's already, to be fair, this isn't totally novel. There's already architectures on scene detection and things of that nature. But in the same way we're seeing multimodality with Clip and these other models, I think there's going to be like a seminal foundation model that links video scenes with image capabilities rather than kind of like piecemeal interpretations. I think the trend of computer vision problems enabling more specificity will continue. So, classification problems were the first thing that were unlocked, object detection problems, and then segmentation problems growing in usage and prominence. And this is, to be fair, I still think that object detection solves the vast majority of what people are actually usually after: counting things, checking the presence of things, being able to have a model that runs incredibly quickly. The data collection needs are also much slower. So I still think that will be a total foundation in computer vision and perhaps underrated. And at the same time, as compute gets cheaper, gets pushed to the edge, and these other sorts of improvements happen, especially on the labeling side, I think we will see a growth of segmentation use cases as we see things that need to get more and more granular. Karpathy, Tesla's head of AI, and computer vision, has noted that they actually try to frame as many problems as they can as object detection problems precisely for this reason, which makes, I think, this prediction that we're going to see the shift perhaps that much more novel. And then the last note is richer than ever semantics. As we mentioned, linking together image and text allows us to have a much richer understanding of what's happening in an image, what text is associated with attributes of an image for clearer and better sorting and filtering of imagery. So with that, I've got the predictions out there. I'm vulnerable. We'll see how I do in 2023.
I look forward to you making the prediction that multimodal comes to video again next year. This is going to become your. This is the year of Linux on the desktop, baby. Do we have time for a couple questions? There's some really good ones here. I'd like to get to them. I don't know if you all have meetings to get to immediately after this. But like I said, we've got some good ones.
Those are great slides.
Alexander, yeah, thanks, Joseph. Alexander had a question here. Can transformers be applied to denoising of sensor data, like to reduce noise of pressure measurements, for example?
Interesting. I haven't seen those applications, but I'd be shocked if the answer is no. So I can't point you to specific resources of that domain, though transformers denoising signal processing is a well-established trend. I think actually even Satya mentioned using some of those previously when trying to denoise audio data. So I think the answer is yes, though I'm not a domain expert in the specific portion of denoising pressure sensors specifically to say, hey, here's a paper of that happening.
Our trivia winner, Richard, would like to know, will the move to multimodal, will the gap widen between large corporations and smaller startups that don't necessarily have the same resources?
That's a fantastic question. Satya, I answered the last one first, so you can go first on this one, and I've got some thoughts too.
Large corporations will always have an advantage when it comes to the sheer amount of computing power they can throw at a problem, right? So, for example, but then small companies cannot and should not compete on the same footing as large companies. For example, I'll give an example is Yoshua Bengio's group. They have, he's a Turing Prize winner along with Dr. Jan LeCun and Dr. Jeffrey Hinton. So his group, they say that they come up, it's a research group, right? But still, they say that how do they compete with, research group in the industry? They have so much more funding than Dr. Bengio's group. So what they do is they come up with new ideas and they push the idea forward to a point where the industry can pick it up and run with it, right? The industry doesn't have an appetite for novelty in that sense, right? They cannot fail. So his group takes ideas to a level where the industry can pick it up and run with it. And he stops research in certain areas once he sees that the industry has picked it up and running with it, right? Now you cannot compete and you should not, right? That's not your domain. And people may remember this framework called Theano. It was very popular. It was from his group for machine learning, deep learning. And it was at its peak when it had the biggest adoption. He shut it down because PyTorch had come along, TensorFlow had come along, and they were very good frameworks. Why invest your time and energy into something that is not going to be as good, and you're competing with the big guys? Spend your time and energy into things that will be useful. So for that comes from your strength, your intellect, or your experience, or your things that you can do, but big companies cannot do, right? So the answer is yes, but focus on things. The small companies will have to focus on things that make them unique, right?
That's a great answer. And there's an old quote, I can't remember where I first heard it, but I think it holds true in a lot of situations, which is the best way for a small company to fail is to act like a big company.
Yeah.
They just have totally different needs and things that can help them. And I think that's great to keep in mind. Joseph, do you have any thoughts on that?
I think it's a great thing to call out that the gap between companies growing. I think maybe perhaps think about it less like the gap between companies and the gap between technologies and what that means for enabling the democratization of those technologies. So for example, in the same way that data centers have paved the way of what it looks like when you aggregate a significant amount of compute in a single spot, and then you offer data centers as a service through Amazon EC2, Google Cloud, things like this. I think we're going to see a similar trend, and this is what OpenAI's bet is that they can train mega models, that they have the resources and expertise to do, and then they can offer those as a service in ways to other sorts of companies. And so I think it's, I don't know that necessarily, the technology is so valuable that it would surprise me if the even society optimization as well as profit maximization decision is, oh, we're going to keep this only to ourselves. In fact, I think it's going to be much more, how do we enable access to this? And the other thing that I'll say is that is the gap going to get bigger between companies? Not if RoboFlow has anything to say about it. The ability to empower anyone to have access to this technology, companies big and small, and empower developers to be able to be successful is core to our ethos. And so I think that we'll continue to enable developers of all stripes to take advantage of leading advances in technology.
Great segue into that pitch. Just golf clap over here. I think we got time for one more here. Ahead would like to know, are you familiar of any applications that combine voice recognition and computer vision for natural language processing?
Vision for language processing, or
voice recognition for processing, and then computer vision. So similar maybe to like our Clip and GAN stuff, but with voice.
Yeah. I can't say I'm familiar with vision applied to speech recognition problems. I can give some recommendations for speech recognition, certainly. I mean, I think Assembly AI is a company I would certainly check out that has APIs that often outperform. We were talking about how do big companies and small companies compete. They've sort of taken this one sliver of the stack and delivered a much more performant and let alone cost-effective way of interpreting text is one place that I would look. In terms of research of multimodal audio transcription, I don't know is my answer. I don't know if that research exists. I'm not aware of it. If it does, though, I think that there's probably a good case to be made that in the same way that we're seeing seminal research linking together different domains, I could see that very similarly linking together audio with perhaps transcribed or even regional dialects and things like this. One thing I will note on this note is transformers are actually what enabled Google Translate. I don't know if you noticed, maybe it was like 18 months ago, it just magically got like way better. That was under the hood of what was happening. Again, that wasn't a multimodal change, but it does hint at some of the same trends we're talking about in today's conversation.
Yeah, Satya, thoughts on that?
Well, I don't have a specific example, but it's easy to see. You could be commanding your robot to clean your house. Once you do voice, so it basically converts your voice to an action text. Yeah, and then it interprets it, and finally it goes and cleans your house, which is done using vision, right? At least part of it is done using vision. So all three things are used in conjunction, and that's not very uncommon, right?
Yeah, definitely. We're about 15 past the hour. You want to take us home, Satya?
Yeah, thank you so much, Joseph. It was really entertaining. I really liked the presentation, and as always, the people got a lot of value. And thanks, Phil, for organizing this. And finally, thank you so much, our audience. You guys show up every week, and it's a pleasure to be just here and talk to people like Joseph, who provide so much value. And it is only because of the support of people. It encourages us. So please keep showing up every week, and we will be here next week again.